In this video, we will have a closer look at the min-max block and explore how to make the best of this powerful functionality. The blocks help you query your graph at different levels of depth. So, for instance, if we want to know who Claire Molson is the child of at 1 degree of separation, this will return her parents. Now, if we change the level of depth to 1 from 1 to 2, this will return both Claire's parents and grandparents, like so. On this graph, we clearly see Claire's parents at 1 degree of separation and her grandparents at 2 degrees of separation. And of course, if we increase further the level of separation, we get 1 over grandparent. Now, notice that at 3 levels of separation, we only get 1 extra node, and this is because we have no information about the other grandparents. Keep this in mind as we go back to the advanced search and change the minimum parameters to 3. Effectively, now we are asking the system to only return a path which connects the start node, in this case Claire, to an individual node at 3 degrees of separation with only child doves as connection between all those nodes. In this case, only the path between Claire and Geoffrey is returned, because only Geoffrey has 3 degrees of separation from Claire. If we change the parameters to a minimum of 2 and a maximum of 2, then we get all the parents and grandparents. And the parents are only returns because they're part of the path to the grandparents. Up to now, we've asked queries from a specific node. But of course, you can always use the min-max block between node classes. Here, for instance, we ask to see all the individuals that are connected to other individuals through a child-of connection at 2 degrees of separation. And we get the following 3 clusters. Once we have organized the canvas, we can see that the first cluster is straightforward to understand. We have one individual, Jessica Smith, connected to her father and grandfather. On the second cluster, the reason why we have 4 nodes is because we have 2 degrees of separation between Jackson and John, but also between Richard and Anthony. The third graph is Claire's family, which we have already explored earlier. Up to now, we have focused on examples with directed connections. When you use the min-max block with undirected connection, it is important to understand the limitation of the system. So, if we ask to see any friend of between individuals at 1 to 2 degrees of separation, there are no issue. All the relevant data is being returned. However, if we now change the minimum degree of separation to 2, we are getting the same result. And this may seem weird at first, but the result is actually logical. Consider this pair, for instance. The system considers this connection both as Jackson English is friend of John Black, but also John Black is friend of Jackson English. We can tell the system to ignore already visited relationship by toggling this button. However, in this particular instance, doing so will not return anything, because by definition, undirected connections are always visited twice. However, if we now narrow the query and ask to only see Jane's call-based friend at 2 degrees of separation, we get a result, because this time, the system starts the graph from a known node. Another idiosyncrasy of the min-max block is how it deals with intermediate nodes. Consider this example. I'm asking to see all functional connections to entities at 3 degrees of separation. The resulting graph returns a mix of entities and individuals, even though we only ask for entities. And this is because the min-max considers only the parameters of the two nodes at the edge of the graph, not in the intermediate steps. Only the connection parameters is applied throughout the graph. So here, all the connections are either works for or member of, which are both functional connections. As for all the nodes, we can see that all of them connect to entities at 3 degrees of separation from Jaynes-Kolbe. Here we have one path, and here another, and another, and another, and another, and some more here, and one more there. But you may wonder why John Black and Jackson English are being returned. They clearly are not entities. Well, this is because we have asked to see all functional connection, meaning we are not only looking for works for, but also for its mirror relation, which is as worker. So those two individuals are returned because they connect Jaynes-Kolbe to Big Buck Management at 3 degrees of separation, like so. To filter out those sorts of false positives, you can use the ignore already visited relationship, like so. And you can see that indeed the two individuals have been removed. Let's try a similar query, but using actual connection type rather than categories. If I ask to see all entities connected to Jaynes-Kolbe between 1 and 3 degrees of separation, we only get the following 3 nodes. However, from our previous examples, we know that there are many more companies that should appear. But all of those companies are connected to individuals which works for the 3 entities on the screen. So in order to retrieve those, and in consequence the other entities connected to those individuals, we also need to add the mirror relationship to the query, like so. Again, we notice that Jackson English and John Black are being returned as false positive, and so is Bill Benson. If I now select the ignore already visited relationship, the graph is being pruned of those false positives. The reason why Bill Benson is pruned is because he is part of both the Jaynes-Kolbe to high flight path and the Jaynes-Kolbe to budget flight path. And so, since we ask the system to ignore already the visited path, this is why Bill Benson is being removed. Finally, if we change the minimum parameters to 3, this will return the same graph, minus the connection to budget fly. The reason why both High Fly and Big Buck Management are returned is because they are part of the path to the Airplane Corporation and Jackpot Asset Management, respectively. In conclusion, the min-max block is very powerful to explore your graph, but it's important to understand its limitation and idiosyncrasy to make the best out of it.